Hi and welcome to video 12 on integration and the integration required for Specialist Mathematics Unit 4 Topic 1. I've got two more examples left of partial fractions I'd like to show you, and so let's roll through them now. So in example 3, I've got a question that looks like this. It looks like it might simplify quite nicely, but it doesn't. The problem we have is that I've got a higher power on here than I have at the bottom, and that's not allowed. So if that does happen, you've got to think about reducing it like this. So we want to integrate this function. I'm going to write this down as x squared times x squared minus 4. That gives me my x to the power 4, but it also gives me negative 4x squared, which means I have to add 4x squared, and I've still got that minus 4 in the end. I've done this for a very particular reason. So I've chosen to get myself the x to the power 4, but also build my denominator in there as a multiple, because now I can divide through that part, which gives me the integral of x squared, because that cancels out, but I'm still left with 4x squared minus 4 over x squared minus 4. Now I still have this problem because that power is equivalent to that power, so it's still not small enough, which means I can do this again. Let's process again. I get x squared. Now I need to get 4x squared, so I'm thinking I'll have 4x squared minus 4. Now I've got the denominator there, but of course I have subtracted negative 16 in that expansion, so I have to add 16, and I've still got my minus 4, and that's over x squared minus 4, and this becomes x squared plus 4, but I've still got 16 minus 4 is 12 over x squared minus 4. And so I've still got to deal with the partial fraction, but I've got that fairly easy polynomial component as well. So now I would take this and I would do my little partial fraction calculation. So 12 over x squared minus 4 is equal to 12 over x minus 2, x plus 2. So this is a fairly easy partial fraction, and that's equivalent to a over x minus 2 plus b over x plus 2, and I do that multiplication, x minus 2, x plus 2 multiplication, giving me 12 is identical to a x plus 2 plus b x minus 2, and so this is 0x plus 12 is equivalent to a plus b x, and then plus 2a minus 2b, and so I get a plus b is equal to 0, 2a minus 2b is equal to 12, and that gives me, of course, a equals negative b, so I get negative 2b minus 2b equals 12, it's negative 4b equals 12, b equals negative 3, a equals 3, and I can bring this back over into here now. So this is now equal to the integral of x squared plus 4 plus a is 3 over x minus 2, and then minus 3 over x plus 2 dx, and that's obviously, I'll say obviously, 1/3 x cubed plus 4x plus 3 log x minus 2 minus 3 log x plus 2 plus c. And that's pretty much the best way to write it as well. That's example 3. And finally, this is a question that's geared towards you always being a bit thoughtful about the types of questions you might get. Because you have a look at this question and the immediate thought is, well, this looks a lot like a partial fractions question. And I'm not going to lie to you, it is a partial fractions question, but there's a simplification process that can happen first. So let me take you through this. The first thing to recognize is that we've got a cubic on top, and this is, when expanded, a cubic. So there has to be some simplification that takes place anyway. But it turns out that this cubic, x cubed minus 8, can be written as x minus 2, and then we're left with x squared, we're left with plus 4, and if we have a plus 2x in the middle, well, this works out. Now, how can we make this work in our minds? How can we see that that's got a factor of x minus 2? Well, remember, back in math methods, the old factor remainder theorem, etc. If I put 2 into that, I get 2 cubed minus 8, which is 0. So I know that 2 is a factor, and well, 2 is a 0, and therefore x minus 2 is a factor. So this is the kind of thinking at complex familiar and complex unfamiliar that needs to take place to get these questions out. So what I can do now is I can write this as the integral of x minus 2, x squared plus 2x plus 4, all over x minus 2, x squared minus 1, and these now cancel out. And I'm left with this, x squared, I'll do the actual line of working, but you could maybe skip a line of working there. This is x squared minus 1. I can factorise x squared minus 1, but I'm not going to do that just yet. I've had a look at x squared plus 2x plus 4, and that doesn't factorise. So instead, I'm going to do this, x squared minus 1 on top, and I'm left with plus 2x plus 5, and that's over x squared minus 1 dx. And of course now I can cancel this out with this, and it leaves me with 1, and keep in mind how the cancelling out works. I've still got 2x plus 5 over x squared minus 1. There's not much I can do with that. And now we're down to the final simplification process. So that integral of 1 is going to be easy, but I'll leave it there because I need to do, in fact, I'll do my partial fractions over here. So this is 2x plus 5 over x minus 1, x plus 1, and that can be written as, well, it's identical to a over x minus 1 plus b over x plus 1. And if I do that cross multiplication, I'll multiply by everything in this denominator. I'll come out with 2x plus 5 is identical to a times x plus 1 plus b times x minus 1. So 2x plus 5, I'll skip a little bit of working now. I get an ax and a bx, so I get a plus bx, and then I get an a and a minus b plus a minus b. And so therefore a plus b is equal to 2, a minus b is equal to 5. If a minus b equals 5, then a equals b plus 5, and I get 5 plus b equals 2, 2b equals negative 3, b equals negative 3 over 2, or 1.5, and if b equals negative 1.5, then a equals 7 over 2, or 3.5, just based on this equation here. So there's my a and my b values, and I can take that back into my integral now, and say I want to find the integral of 1 plus a, which is 7 over 2 over x minus 1, plus, well, I'm going to make it minus b, which is 3 over 2 over x plus 1, and it was b is negative 3 over 2, but that's now there, dx, and I can do these calculations. So I get x plus 7 over 2 log x minus 1 minus 3 over 2 log x plus 1 plus c. Now it might be tempting to throw the two logs together using that negative and a division, but I have to incorporate these coefficients inside the logs first as powers, and so it gets a little bit more complex and it's probably not worth it. So there we go. There's an integral of what looked like a cubic over a cubic, but it can be simplified, so keep an eye on that, and remember that you can apply things like your factor remainder theorem and anticipate that that's what's going to happen in those complex familiars, and particularly complex unfamiliars. You're going to get questions that rely on past knowledge from specialists or methods from the last couple of years, so definitely be thinking about what might happen there. So that's the end of our partial fractions lesson. Make sure you ask questions, practice through the exercise, and don't leave any stone unturned. All the best.